Hi, now that you've had a go at question four, uh, hi, now that you've had a go at question four, all about map D in your theme 14 booklets, let's have a look at some answers. The first part of the question asks you to look at cross-section D and use that information to try and interpret what's going on the map. So the first thing was to mark on some dip arrows. We can see that on the cross-section, the dip of the beds on the left hand side, on the western side of this map, is towards X, and on the right hand or the eastern side of the map, it's towards Y. Dip, remember, always goes down. So on our map, we can mark these dip arrows with the triangles pointing there in the direction that the rocks go down. I then ask you to measure the angle of dip. We always measure dip from a horizontal line. If you put a protractor or an angle measurer on these dipping beds, we'll see they're dipping about 45 degrees. To work out the interlimb angle then, the angle between the two limbs, we add those two numbers together and take them away from 180. So the interlimb angle here is 90 degrees. It's a right angle between the two limbs. I then asked what type of fold we're looking at here. We can see from the cross section it's an upfold. Your dip arrows are pointing away from each other, so it's clearly an antiform. We then need to draw on the axis of the fold. The axis of the fold is the middle of the fold, where we actually see a bit the symmetry of the fold. So that's going to be running there through the middle, with the correct symbol there for an antiform, like a diamond shape. We can see from map D that these rocks have been folded. There's two ways we can tell. We've got dip arrows in different directions, and we've got a repetition of beds. We can see that coal seam there appearing twice. Now, if the fold is oriented north-south, in this case, the stress that produces it is going to be at right angles to that fold axis. So the stress here has got to be coming from east to west. We then have some data from this borehole, giving us the depth to these different beds. Let me just draw on what the correct answer would look like. So there you'll notice we've got the correct sequence of beds. We also have the right thickness of beds drawn on. And also notice how those beds are folded just like the younger ones that are above them. Now, those of you that dug deeper were asked about the potential for this as a potential trap for hydrocarbons. It is possible. It is an antiform. We know we get antiformal traps. And we've got the right sequence of beds. We've got an organic rich shale sitting below a greywacke and a desert sandstone that will have some permeability and porosity. So you have got a source rock, you've got a reservoir rock, and there's a shale above that to act as a cap rock. However, it's not very deep. Most hydrocarbon traps are going to be a bit deeper than this. Certainly the rocks have to be buried deeper to mature the hydrocarbons to produce oil or gas. Check your answers against these. If you've got any questions, contact me.